Today we're going to be assessing a problem that has a 32-inch side, a 40-inch side, and a 50-inch side in a triangle and has a geometric sequence. So a common geometric sequence that is often used is s to the n equals ab to the nth. So we're going to determine what s to the 0 is to get this problem started. So we're going to say that s to the 0 equals 32 because b to the 0 would be 1. So therefore a is 32. So we're going to write that a is 32. We're also going to write that s to the 1 is 40, which means that we can use that to solve for the b value. So we're going to say that 40 is equal 32, which we put in as a, b to the 1. So what that means is we're going to divide by 32, and we're going to get b to the 1 equals 40 over 32, or 5/4. Now this means that we can plug this back into our equation, which is into our geometric sequence equation, which is Sn equals 32 5/4 to the n. But we're not done there. The next step in the problem is using the triangle inequality theorem, which states that the absolute value of b minus c is less than a, which is less than b plus c, or the differences between the lengths of two sides is smaller than the length of the third side, which is smaller than the sum of the two sides. So what we can establish in our problem is that a is going to be equal to s equals 0, established as 32. B is going to be s is 1, which establishes 40, and then c is going to be s equals 2, which we established as 50. So what we're going to use is the fact that the s to the n equals ab to the nth, which is the same equation that was used above, and then s to the 0 equals a, because b to the 0 equals 1, so that's only going to be canceled out to be a. S to the 1 equals a times b, because b to the 1 would just be b. And then s to the 2 is going to be ab to the 2, which you could follow on for even s to the 3 equals ab to the 3, but that's how we're going to stay for this equation because we only have 3 sides. So now that we have these values established, what we're going to do is we're going to take the triangle inequality theorem and apply it to our problem. So what we're going to say is that s1 minus s2 is less than s to the 0, which is less than s1 plus s2. Now we're going to take what we know here and establish this problem. So ab minus ab squared is, in the absolute value, is less than a, which is less than ab plus ab squared. Now what we're going to do is factor out a from these equations. B minus b squared is less than a, and which is less than b plus b squared. And another way that you can write a is also 1, because s to 0 can equal 1. So what we're going to do is write 1. So now we have two equations. So we're going to take these two equations, and we're going to say that b minus b squared is less than 1, and 1 is less than b plus b squared. Now we can do some algebra to solve this. So once we have these two equations, we have this one and this one, we're going to factor over 1, so subtract 1 from each side, so you get b minus b squared minus 1 is less than 0, and b squared plus b minus 1 is greater than 0. And then using binomial and trinomial factors, you can find that y is less than these two values and y is greater than these two values, which you need to factor out the negatives because side length cannot have negative values, and what you get is that the rate is between 0.618 and 1.618, and that's the correct answer. Awesome, thanks for listening.